Hi everyone, today I'm doing the examples from exercise 14.4 and this is the last exercise with examples from statistics. So we're starting off looking at confidence intervals and we'll get straight into the examples, and I think as we go, we'll explain what it is and how it works. So there are 20 people in your class and 25% are planning on buying their lunch. Estimate the proportion of the school population that will purchase their lunch today. And finally, find a 95% confidence interval for your estimate, given that z equals 1.96. So let's see what we've got. They're asking us to estimate the proportion of the school population. So the school population would be big N, and our population proportion, well, that's what we're estimating. What we've got is little n, which is our sample number, which is 20, and we've got a sample proportion of 0.25. Remember, you're going to put it in a decimal, not a percentage there. So this z equals 1.96. We'll deal with that in a minute, and what that is to do with is the formula for our our confidence interval. So I'm going to just scroll up, and here we have a picture of where we have 95% of values in the centre. So if I wanted to find the z values for that, then I would go to inverse norm. And in inverse norm, I would have my tail at centre. And be careful with using the centre tail, because the centre tail means that it is specifically centred. So as the name suggests, people will use centre for just when it's, two ends. So if you've got something where here's the mean and then you've got your two ends here and here, that's not centre. That's you'll have to use left and right tail to do that one. Centre is when it's actually centred about the mean. In any case, for the sake of confidence intervals, it's always centred. So our tail is centred, and our probability is going to be 0.95, and then we can just leave our standard deviation and mean as they are, because we're looking at a z distribution. And if you were to put that in and press OK or EXE, whatever the button says there, you're going to get 1.96. So that's where these values come from. And we are often asked to find a 95% confidence interval. So that's where we're using 1.96, because that's the z value for 95% in the centre. However, it's not always like that, and we'll see a question in a minute where, it's not. So it's important that you read and see what confidence interval they're asking for. And if it's something other than 95%, you're going to have to find your value in the same way, but obviously putting the specified confidence interval in there in your probability. So look, let's head back to the current example, and our formula for a confidence interval is going to be p hat minus, I'm going to write z here, not 1.96, p hat 1 minus p hat over n, and then p hat plus 1.96 p hat 1 minus p hat over n. So in this case, our z value is 1.96. A, because they've told us, but B, because if you were to work that out on CAS using inverse norm, as I said, you would get 1.96. So let's sub in the values that we need. So p hat, our sample proportion, is 0.25 minus 1.96. P hat 0.25, 1 minus p hat, that's 0.75, and n is 20. And then again, 0.25 plus our z value of 1.96. P hat is 0.25 times 1 minus p hat, 0.75 over n, which is 20. And look, you might like to work out what this part of it is. so that you can just plus or minus them. I've put it into the formula there so you can see, you know, how it works a little better, but by all means do that first. It'll make it a little easier. So look, the values we get here are going to be 0.0602 and 0.4398. And that's our confidence interval, that's our 95% confidence interval. But if we interpret that, like if we want to know what that's actually telling us, well, it means that, I'll put it over here, we can be 95% confident that between 6%, so I'm just multiplying by 100 of course, and 44% of the school population will buy their lunch today. So it's not really, I mean, when I see a statistic like this, it's not very, it doesn't tell you too much. I mean, 6% and 44% are a very large range of values there. So we're saying, well, you know, based on the population, or the sample, which is the class, we're gonna say that, you know, we're pretty confident that between 6 and 44%, or very confident, really 95% confident. If we were to use a lower confidence interval, we would say, well, let's be 70% confident, then this number here, or this range of values here, would be lower. So, you know, you could be less confident than a smaller number. The other way that you could, I guess, improve your confidence would be if you were to have a larger sample size. And the larger sample size, obviously, that's the denominator there. So if you have a sample size of 200, well, then that's going to give you a smaller value for these. And that means that your confidence interval overall will be smaller. So you would be able to say you're 95% confident that between 20 and 30% would buy their lunch, or 25 and 40%, or whatever it might be. So in this case, a very large confidence interval for 95%, but you might like to try with different confidence intervals or different n's, so different sample populations, and see what you get and how that affects it. Let's move to the next one with Paul sampling people who like coconut milk. And he's asked 102 people. So in this case, well, n is our population. And that's what we're trying to estimate, the proportion of the population. So we're trying to estimate this. That's our goal, to estimate the population proportion. What we have is a sample, so a little n of 102 people, and a sample proportion of 18 of them out of 102 who like drinking coconut milk. So that, if we decimalize that, is 0.18. And, well, now we can go about doing a 99% confidence interval. Now, I like it because they've given one that's not 99%. So I'm going to put Z here, and I'm going to find that. So on your CAS, here is our 99% centered. And then we go to inverse norm, as per usual, because we're trying to find values here. And in inverse norm, we're looking at a Z distribution. So our mean is 0, our standard deviation is 1, of course. And that means that our Z value for these are going to be 2.58. And we'll negative 2.58. Now, I'm going to find so from the formula, so remember our formula up here, this was for 95% because it had 1.96. But remember how it's quite annoying to have to write, this thing twice. So I'm going to find that value and then plus or minus it so that it's a little easier for us. We don't have to do it twice. So let's see. We've got our Z value and times our P hat, 1 minus P hat over N. And let's find out what that's going to equal. So the Z value of 2.58. That in there, and then P hat is 0.18, 1 minus 0.18 is 0.82, and N is 102. So when we pop that into CAS, we're getting 0.098. And now, well, this is what we're plussing and minusing. So in our formula, remember how the confidence interval is P hat minus Z, P hat 1 minus P hat over N, comma, P hat plus Z, P hat 1 plus P hat over N. So now I can say, well, I've got this value, so I just need to plus and minus it. So my P hat was 0.18. So we're going to minus 0.098, and we're going to have 0.18 plus 0.098, and that is going to give us 0.082, comma 0.278. So this is our confidence interval here. So if it asks you for a confidence interval, that's the confidence interval. The interpretation of the confidence interval is, and what do we do, 99%. So we can be 99% confident that between, and let's times by 100, so 8% and 28% of the population likes drinking coconut milk. I'll just write a C&M. So this is our interpretation here. The confidence interval is this. So if it asks you for a confidence interval, there it is there. You don't have to do anything fancy. But the interpretation of that is that we're 99% confident between 8 and 28% like drinking coconut milk. So you can obviously, make a smaller range of values here if you wanted to by either increasing your sample size, or you could decrease your confidence. So you could put to 90% confidence and you would have a smaller range of values. You could put to 80% and then be even smaller range of values. So there are confidence intervals, 2 examples there, and the big thing I really want to make sure people know is that, the Z value is important. It's often that you're asked for a 95% confidence interval. So as I think I've mentioned a couple of times, here it gives us for 95%. And because we use that so much, people start to think that the formula always has 1.96. It doesn't always have 1.96. It's the Z value for the specific confidence interval that you're being asked to find. So I think this is our last example here, yes, and this is the margin of error. So let's see what we're gonna get. So Growell are 95% sure that 30 to 40% of shoppers prefer their mulch. What sample size would be needed for this confidence interval? Okay, so this is a bit different. It's telling us there's a 95% confidence interval that between 30 and 40%. So this is essentially the answer to a question like example 10 and example 9. So that's what we found. But this time they're asking us for a sample size. So what I'll do first, it's between 30 and 40%. So I'm going to have P hat is going to be right between those, so it's going to be 35%. And if they were values that it's not easy to see the middle, you can do the average. So you add them together, and I might just do that. It's unnecessary in this case, but for the sake of just, you know, showing you the way. So 35%, so p hat is going to be 0.35. Okay, so we also know that our Z value, because, well, it's a 95%, we're 95% sure, the Z value must equal 1.96. So let's see. If we were doing a confidence interval, well, we would have p hat minus Z, p hat 1 minus p hat over n, comma, p hat plus Z, p hat 1 plus, sorry, not plus, don't be careful of that, that's certainly not, over n. So the plus and minus only exist here, not in the root. So now that would be our confidence interval. And what we know is that the confidence interval is 0.3 to 0.4, because it's between 30 and 40%. So we're 95% sure they're between 30 and 40%. So now, well, we can find those values. So we get, let's take this one. It doesn't matter which one you use, you'll still be able to solve it. You could just as easily use the 0.4. But obviously if you're using the 0.4, you use this. And if you're using the 0.3, you're going to use this. So let's see, 0.3 is going to equal p hat minus Z p hat 1 minus p hat over n. And n is here. That's what we're trying to solve. It's a 95% confidence interval, so we know what Z is. And well, we know what p hat is because, well, there it is right there. So let's sub in the values. 0.3 equals 0.35 minus Z 1.96, because it's a 95% confidence interval. If it was a different confidence interval, you need to account for that. P hat 0.35 times 1 minus 0.35 over n. And n is what we're trying to find. And of course this will be a CAS question, so you can just solve this on CAS. And if I were you, I'd use x here. I think it's annoying to have to go and use n, comma x. And then, well, it's giving me n equals 349.586. And, well, I'll just round that up because you can't have 0.586 of a person. So sample size needs to be 350 people. So that's how we would find the sample size. So in this case, we have been able to find the sample size that we need based on the confidence interval, and yeah, that's quite handy, and I think quite you can see how this might be a useful type of maths that you could use. So look, that takes care of all the examples from 14.4, and then we do not have any more because 14.5 is the mixed problems. Now, just to note, I was just looking, this formula here for margin of error, we didn't actually kind of need that for the question. I don't know why I stuck that one there. I think I just pointed it out, wanted to point it out. But in any case, we did not actually use that in that question. We used the confidence interval. So just, we will cross that out for the purpose of this example. All right, that is all.